Hi, welcome to my session. My name is thse. I'm the head of thse at Checkmarks. My background includes specializing in building advanced malware research systems to track advanced attackers. This talk, we're going to talk about open source. So open source is great. Everybody is using open source, and it's actually what helps develop product faster. And this is great. Anybody can contribute code to an open source project. This is the main reason why this ecosystem is thriving, and that's great for everyone. We come from a cyber background, so looking at the current ecosystem, we actually thought to ourselves at thse, developer move fast, and that's great. But do attackers contribute code as well? And if the answer for that is yes, can we detect them? So we spent a couple of months and researched the attack surface, studying all the latest attack and checking for ourselves what are the most easy to exploit paths to poison a malicious package. And we'll be happy to share with you what we have learned, and we are still learning today. So the problem, as we realized after spending a couple of months researching it, is that the current application security solutions are really focused about detecting vulnerabilities. They were never built to detect attackers in code package. What do I mean? Most of the code used to be written by a developer that was a direct employee of my company. So all I wanted to do was to make sure that he doesn't have any bugs in the code that he writes. So all the current stack of security tools were actually, let's help our developers make sure that their code is actually clean. So that code doesn't contain anything that is a bug, and a bug can lead to a vulnerability. But the ecosystem was never actually built to detect attackers in code packages, malicious developers with malicious intent. So this is why this trend of software supply chain attack is gaining more and more popularity, because the current solutions out there are not focused about that. They are more focused about vulnerabilities. So as I said, software supply chain attacks are on the rise. It seems like every other week we hear about a new software supply chain and a new malicious package being uploaded. So let's look at a couple of those examples and what can we learn. One of the major incidents I'm going to talk about happened a couple of months ago, and I'm referring to the PHP incident. What happened in this incident, in case you don't know, was an attacker was able to add a backdoor into the infrastructure of the PHP project, and he actually was able to add a commit, which he called a fixed typo, and you can actually see the commit inside the code. What he tried to add is a couple of lines of code that actually says that every PHP server is in the world, and there are a lot of PHP servers in the world, whenever we'll see an header called HTTP user agent, and the mistake is in the source, that starts with the string Zeridium, it will automatically execute the code inside that header. This basically turns every PHP server in the world to a backdoor. Luckily for all of us, this was discovered. And when it was discovered, that piece of code was removed, and the PHP team, security team, actually had some mitigation in place. But looking at this incident from a cyber point of view, dealing with attackers for many years, you quickly realize just removing the malicious part won't solve it. This is not an isolated incident. This is an attacker. Do we really believe that this attacker will not try again? Do we really believe that this attacker is only focused on PHP and he doesn't care about other languages or other projects? If we extract what we learned from this incident and go hunting in other projects, and if not, how successful will be our protection going forward? So this is like the current mindset. If we find something bad, we remove it and we move forward. I will give you more and more examples going forward. So the reason this is so successful is that the entire ecosystem was actually built on trust. And I will show you a new TTP that was discovered last year. It was discovered not in an attack, but a white hacker actually published it and actually notified the companies. Using this new technique, he was able to hack into Microsoft, Apple, Uber, and a dozen of really high-level important companies. And when he reported this issue to a couple of the vendors, he got a response, this is not a bug, this is a feature. So let me explain what he did, and we can understand the mindset behind the open source ecosystem. So usually what happens is when I'm writing my own code, I won't write everything from scratch. Basically, I do what we call plumbing. I take a couple of an open source library that will help me to achieve my goal, and I add the code in between them to wrap everything together. In this example, as we can see, I'm using 3 packages. I'm using Flask and Angular, which are quite popular Python packages, and I'm using my own company package. Let's call it Dustico Infra. It's an internal package used by developers in my company. In this case, when I'm ready for the build process, it will be sent to an Artifactory, and the Artifactory will get a list. It says we need Flask, Angular, and Dustico Infra, for example. And that's the problem. It doesn't mention private or public, anything, just anything like that. Just what does the developer want? So the Artifactory will reach out to a popular public repository, for example, Python in this case, and will ask, do you have Flask, Angular, and Dustico Infra? For the first 2, we'll get a positive answer, and we will download the latest version of them. For the third one, he has an internal copy. He will use his own local copy of Dustico Infra, add it into the build, and so the release will finish successfully, and my program will work. This is the expected behavior. What was discovered by the white hacker? So this is the expected behavior. Now, let's look what's the malicious intent. Let's start again. I'm writing my own code, like Dustico Infra. I'm using Flask in Angular. What is different this time is an attacker was able to guess the internal package name. He managed to guess that there's probably a package called Dustico Infra, and he registered that on Python, and he actually gave it a higher version number. Can you guess why? Let's see. So I'm actually doing the same process I did before as a developer. I'm writing my own piece of code. I'm specifying that I will need Flask, Angular, and Dustico Infra. This is being sent to the Artifactory. The Artifactory will go out and reach the Python and will ask, guys, do you have Flask, Angular, and Dustico Infra? This time, the answer will be yes for Dustico Infra. So the Python says, I have Flask, Angular, and Dustico Infra, and Dustico is actually a really high version number. So a lot of time the developer will specify he wants the latest versions. So in this case, what will happen is that the malicious package will be downloaded and will be put inside my project. And when the build process will be completed, the malicious package will be part of my code, which is not what we intended to do. So this is very bad. And it doesn't take a lot from attackers to do that. That's the reason why we saw so many copycats doing that just after those technique was discovered. We released a tool called Dustilo. What this tool actually does is when you see a private package name, it will make sure that this package name is not occupied by a malicious package in the public repository. So this is very important for people who haven't done the mitigation in place or are not sure what will happen. There are a lot of mitigation guides out there. I would recommend the Microsoft one. I really like all the different ways you can mitigate the risk. It's per language, per environment, but Dustilo is also out there for a quick remediation until you have the chance to change the entire namespace of your packages and names and etc. So this is just one example of why is it so difficult to protect, because we trust everybody. We have no concept of private and public. We take code whenever we found it. And the truth is, usually the person who is in charge about taking the code is not the CISO, which is more security oriented. It's the developer. And the developer has a productivity mindset, meaning he would want to get the job done as fast as possible. So whenever he finds a package that seems right for him and it works for him, that's it. So we need to think how can we make the ecosystem safer for him. So looking at the entire stack out there, why isn't it being protected right now? What we realize is that most of the solutions out there are more reactive versus proactive. And let me explain. Usually what happens is when a malicious package or a vulnerable package, to be honest, is found, it will be reported to a central repository of vulnerabilities, for example, NVD. And then I have plenty of tools that can say, okay, you have a problem with this package, please update it or remove that. The problem with that is that the time for a package to be discovered could be months. During our research, we were actually able to see that the average time for a malicious package to be detected could be something between half a year, even for more than a year. And that's a really long time to be exposed. We call this mean time to detection. So if the mean time for detection is so long, who would like his company, his network, his code to be compromised? So waiting for somebody else for months to detect there is a problem, and then realizing I need to patch or I need to update my code, it's problematic. We need a more reactive approach, not a more proactive approach. The other thing that we noticed is that most of the industry really relies on static signatures to detect vulnerabilities. And that's really the best way to go when you're looking at the entire logic in front of you and trying to minimize false positive. This is not the case here. We have in the cyber industry for more than 2 decades have learned not to rely solely on static signatures, because if there is an attacker on the other side who knows that I'm trying to catch him, static signatures are a really low bar for him to get away from. So again, the entire ecosystem was never built with security in mind. There are projects out there which are great, well-maintained, well-secured projects, like packages coming from Red Hat, packages coming from the Open Source Foundation or the Linux Foundation, to be honest. But not all projects maintain the same level of standard and security. And it's a bit problematic for my developer to try to realize what standard he should follow, what's the right way to go forward. And even if he tries to do that, sometimes he needs a couple of packages that are not inside those projects. So what should he do then? So just to give you a couple of examples, I'm going to show you a quick demo of a technique we call starjacking. The concept behind it is to let you understand how difficult it is for a developer to do the judgment for himself, and maybe raise a bit more awareness and understand a couple of things we need to change. So let's dive into the demo. So what you're seeing right now is what we call Package Lab. It's actually the Swiss Army knife that we use for demonstrate supply chain issues related to open source projects. We have a lot of issues to demonstrate, but this time I'm going to focus on starjacking. So let's go ahead. So what we're going to do, we're going to create a new Python package so I can demonstrate what starjacking means. So first of all, I'm going to use a Python account for this demonstration. And now we're gonna choose a package name. For example, let's choose for our session intent, and let's choose a version. Let's say 3.2.1. Great. Now, when I'm uploading a new package into the Python repository, which is what I'm intending to do, I can actually specify where my code came from. So I don't have any code ready. So what we're gonna do, we're gonna actually pick some random trending project on GitHub as my Git repo. And I'm gonna use, for example, this one. One second, guys. Sorry for that. So going again, guys. So what we're gonna do when we are uploading a package is actually choose where my code came from. So I don't have anything ready right now. So what we're gonna do, we're gonna go into the trending repositories on GitHub, and then just choose like a random repo. In this example, I'm gonna choose Uptime. I'm not actually familiar with that project indefinitely. So let's take the URL and place it here. So what I'm saying I'm publishing a package. That will be the name, that will be the version. That's I'm adding a piece of information for where I'm suggesting that my code came from, or where I'm claiming that my code came from. And now, let's put some code inside this package. Actually, I'm going to use like a really small bit of code, just check what's the latest Bitcoin value at this moment. So let's see. We actually choose the package name, choose the package version. We are using a generic account only for this demonstration. And we're going to use the username. Let's go ahead and publish the package. As you can see, this is a live demo. I'm a bit brave doing the live demo right now. And let's look at the package. So as you can see, this is like the name we have chosen. This is the version number. But what I want to make you aware of is when a developer comes into a package, he has no idea how well maintained the package is, how safe the package is. So a lot of time, what he will do, he will actually look at the statistic of the package. And although this is a new package we've just created, we can actually see it has a lot of stars and a lot of forks and a lot of open issues. So this, in many cases, will be what will give the developer the confidence to choose this package. But we know we've just created this package. So where are all those statistics coming from? So basically, they are coming from the link we have chosen in the package creation, because there is no validation. Nobody actually is checking that the code actually comes from the repo that we are saying, and we're actually like taking all the statistics and taking the stars. So this can quite easily lead into a place where we call star jacking, meaning a developer can quite easily be fooled into picking the wrong package. So this is the ecosystem. We are not giving the developer enough tools to choose the right packages. And it's not a problem only with Python. We have found the same issues in other languages. And there are actually open pull requests to fix that. So we just need, as a community, to make sure that we will develop we will actually be able to develop for our developers a safer environment. So I hope you enjoyed star jacking. And so the other issue I wanted to introduce you was a research we just did recently. So there is a collection of an open source, a malicious open source package out there called Backstabbers. So looking at this, we actually thought, that's interesting. Usually what happens is when an open source package is being identified as malicious, it can be either deleted, or it can be removed and a generic warning like security holding will be placed and said, this used to be a bad package. Coming from a cyber background, we understand that we maybe need to look at the surrounding in the context. So we did like a short research on an old package. It was actually released December 2016, and it was flagged malicious a couple of years ago. And looking at the package, understanding that it's not a single incident, there's probably an attacker behind it. What we did is we went hunting, like we usually do when we are tracking malicious actors. What does it mean? What we actually did is we collected a lot of context of the package. For example, the description, the repository, the home page, the owner emails. We extract the IOCs from inside the packages, like the URLs, the IPs, the domain, the cryptocurrency volatilities. This is a couple of the systems we have in the background running every time we discover or somebody else discover the malicious packages. And then we have a couple of unique import combos to do together. This is what we call the correlation engine. And then we check that not only against Python, but against cross languages. What do you think? Are attacker language specific, or do they try to attack multiple languages at the same time? So what we were able to detect is that although the first package was inactive for years, we were actually being able to detect other packages still active and cross languages. It could be Ruby, it could be Python, it could be NPM. And we use a matrix of user credential, IP, domains, different combos that our correlation engine knows what's the best combination to detect all of them, and we have reported them. So just to give you a small cap. So hunting, which is quite common in traditional cyber, when applied to open source and software supply chain, can quite easily result in new results and new findings that are still out there. This is just one example. Do you think it's the only example? Unfortunately, the environment doesn't support us. What do we mean? When a malicious package, as I said before, is being discovered, it's being deleted or taken offline. We need to build together as a community of researchers some kind of an internal repository, so researchers can go into a package, learn it, and try to detect similar patterns in new packages, in packages from different languages. It's the same thing that a lot of researchers are doing these days with VirusTotal. We found a piece of code. We try to detect something of a suspicious functions about that, suspicious patterns about that. And then we use Yara signatures or Sigma rules or some other type of correlation to try to detect more. So this is not possible today for the entire researcher community because all of those packages are being removed, deleted, and you can't get access to. So we are working together with other bodies in this environment to get together all of those malicious packages so researchers can have access to it. And if you're interested in that, drop me an email. I'll be happy to add you to the project, or we have a lot of packages to investigate, and I'll surely find more and more interesting stuff out there. So as I said, I've started talking about why open source is so important, why the system was built on trust, and the current security toolset was built about detecting vulnerabilities and bugs. It was never meant to detect attackers. Why our attackers are actually inside that ecosystem, and we gave a couple of major examples like the PHP ones. And then we talk about the ecosystem, dependency confusion, trust everybody's code, just check their name. And what I've shown you, starjacking, how easy it for an attacker to fool a developer. And from a researcher point of view, of show you hunting in open source packages, which is a trend I hope will continue going forward more and more. As long as we have the data, we have the techniques, we have the knowledge how to do that. So I hope you found my lecture interesting. Of course, I'll be happy to share any code snippets and everything that I found with you guys. And I really want to thank you for listening to me. Again, feel free to reach out to me if you have any more questions or if you want to be part of the project that we are actually pushing forward. Open source is important for everyone. We need to make some kind of an effort. We need to make a big effort to make it more secure for everyone. Thank you guys, and have a great day.